So, hello dear students, welcome to another live session of Eduins CBSE. Today we will discuss about the subject physics and the chapter is magnetic effect of electric current. So, today we will going to discuss about the magnetic effect of electric current. So, we know the electric current and heating effect of electric current, and after that we have to study or learn about the magnetic effect that causes by a current carrying conductor, and there we know about the solenoids. Okay, let's start our lesson, and before that we have to know what is our motivation today. So, a great teacher doesn't just teach, a great teacher transforms lives. So, teaching is the greatest act of optimism that we have to plant a seed of knowledge today that grow forever. Okay, so Eduins, here's the classes for the class 9 to 12. Okay, so join today, and this is for your seniors, that like classes 11 semester 1 and 2. So science and art students, there is an offer based value of any 4 subjects that only on 3000 rupees, both that covers both the semesters 1 and 2. And the best choice is any single single subject for both semester 1 and semester 2 included only covers only on 1000 rupees. So there is no hidden charges. Okay, so we have to start our study about the electricity and magnetic effect of the electric current, right? So we have to know the magnetic effect of electric current and what is the magnetic effect. So for a current carrying conductor, we have to know the basic terms. For one current carrying conductor, if the current passes through one into other, so from the one terminal to the another terminal, then what will be happening? So there, if we place a magnetic needle or magnet that can deflect the north pole, so there must be some magnetic effect. So this is the examination or this is invented by Hans Christian Ørsted. Okay, so for this, the deflection of the magnetic needle, there present a magnetic field. If there no magnetic field present, then this phenomena never going to be happen. So what is magnetic effect? Electric current and magnetism are closely related. Okay, when electric current flows through a wire, it produces a magnetic field around it. This phenomena is called the magnetic effect of the current. So this is only happen when the electricity flows through a wire. For a static electricity, there occur attraction and repulsion. We all know that. But the magnetic effect, to produce the magnetic effect, there must be a current flowing through the circuit. That produces a magnetic field around it. If we stop the electricity or flowing the current, then there the magnetism is vanished. Okay. So the magnetic effect going to vanish. So this is the magnetic effect of current. Magnet and magnetic field. A magnet attracts materials like iron, nickel and cobalt. Every magnet has two poles. One is south, one is north. The area around the magnet where magnetic force is experienced is called the magnetic field. So we have to know the magnetic field lines where we can find the magnetic field. And to produce the magnetic field, there must be the invisible magnetic field lines. That is much more important. Okay. So what is magnetic field of line? Okay. Magnetic field lines. Magnetic field lines help us understand the magnetic field. Properties they start. So for a bar magnet, if we take a bar magnet, okay, this is the north pole and this is the south pole. So from starting to the north pole and that's going to be aimed at south pole. So what is the magnetic field of line? So if we take a piece of iron here, so it attracts it. For what? For what? It can attract any metallic magnetic metal. How? So there must be a force and the field, force of field. Okay, so this is the magnetic field. So how the magnetic field creates? So here is the magnetic field lines that going through the magnet and it starts from the north pole and ends at the south pole. So this is the magnetic field of lines. So there is some property of magnetic field lines, but there is the key characteristics of the magnetic field lines is magnetic field of lines. Magnetic field lines help us understand the magnetic field. So here we take a bar magnet, that is, this is the north pole and this is the south pole. Okay. Now the magnetic field lines starts from the north pole at east going to end at south. So and there is must be an important point, that is the magnetic field of lines are parallel to each other. That means they never intersect with each other. So the magnetic field lines never intersect with each other. Closer line indicates stronger magnetic field. Okay, so for this magnetic field, if we take this portion, this area, okay, so here the magnetic field of line are closed with each other. Okay, so they are closer to each other. So that's why there the number of magnetic field lines is greater than the other portion. So from this portion, this is greater. So here the magnetic field effects must be stronger. So for magnetic field lines, for the greatest number of magnetic field lines, that means where the magnetic field lines, the number of magnetic field lines are increases, there the magnetic field also increases. So this is the density of magnetic field line. So where the number of field lines is greater, okay, there present the stronger magnetic field because the density of the magnetic field lines is greater here. So that's why. So this is the line, the closer lines indicate stronger magnetic field and the far lines indicate weaker magnetic field. This is the key features or key characteristics of the magnetic field lines. Okay. Now, need preparation for the students of class 11-12 is coming soon. Okay, now the magnetic effect. Magnetic field due to current carrying conductor. So for current carrying conductor, how they produce the magnetic field lines? When electric current flows through a conductor or wire, it produces a magnetic field around it. This phenomena is called the magnetic field due to the current carrying conductor. This was first observed by Hans Christian Ørsted in 1820. So, there in the lecture of 1820, Hans Christian Ørsted proposed that the electricity and magnetism does not relate with each other. To prove this, he placed a magnetic needle below of a current carrying conductor, and he put here the electric current carrying conductor and the magnetic needle in parallel direction. If we put it in the perpendicular direction, there must be no reflection happening. So, luckily, he put it parallelly with the current carrying conductor, and below it he put the magnetic needle. When he passed the current through the current carrying conductor, he observed that the north pole of the magnetic needle deflected to outwards. So from there, he concluded that there must be some relation in the electricity and magnetism, and there must be any magnetic field present in the current carrying conductor on the side of the current carrying conductor. Okay, so that's how the electricity experiment procedure happened. Okay, so how it is discovered by Hans Christian Ørsted. So when a compass needle is placed near a current carrying wire, the needle deflects. This shows that current produces a magnetic field. So we have to know about the magnetic field for a current carrying conductor. So how it produces for a straight wire. Okay, for a straight wire. So at very first we have to know the nature of magnetic field, then we have to study about the straight current carrying conductor. Now the nature of magnetic field, that is the magnetic field lines around a straight conductor are in concentric cycle. Okay, so for this experiment we have to take a cardboard, and between it we have to put an current carrying conductor. Then we have to flow the current in the direction. So there is the current flow is I. Now there must produce magnetic field. Now we have to put here some iron. And when we have pushed the iron or the cardboard, then we notice that the iron oriented at a circular distance, oriented as a circular manner. So that's how the field line works. So the iron oriented like the magnetic field line. So for a straight current carrying conductor, the magnetic field lines oriented as a circular way, at a circular manner. Okay. So, the center must be same for all the concentric circle. So, the magnetic field lines around a straight conductor are concentric circles. The center of these circles lies on the conductor. So, the center lies at any point of the conductor. And direction of the magnetic fields depends on the direction of the current. So, for upward direction, the concentric circles for this orientation, anti-clockwise orientation, and for if we change the direction of the current carrying conductor, then the direction of field line also going to be changed. So, how? At the circular clockwise manner. So, we can know this with the thumb rule. Okay, from the thumb rule. Let's check the thumb rule. So, right hand thumb rule. To find the direction of magnetic field, hold the conductor in your right hand. So, if we take it like a current carrying conductor and we held it with our right hand, then if we point the thumb the direction of the current, so this is our thumb and it directed upwards. Okay, so this is the direction of the current. Okay, now the curled fingers shows the direction of the magnetic field. So that's how the magnetic field lines going to direct it. So for upward direction, it must be anti-clockwise direction. And for the downward direction of the current, that must be oriented in the clockwise direction. Okay? So from these rules, the motor works from the electrical power and the speed of the and the direction of the current carrying conductor. There are some rules, that is right hand rule, Fleming's right hand rule, Fleming's left hand rule. So that's how the motor works. Now we have to study only about the right hand thumb rule. So what will be the thumb rule? If the current carrying conductor, the direction of the current towards the thumb, then the curled fingers are direction of the magnetic field line. So for the current carrying conductor or the direction is in the downward, then the magnetic field in the opposite direction from the previous one. We get this, right? So current upward, magnetic field lines is anti-clockwise. Current is downward, magnetic field is clockwise. So this is the basic knowledge we have to know for solving any kind of numerics or problem solving skill. Okay, now Factors affecting magnetic field strength. So field strength, we know the first thing is the magnetic field of lines. So the magnetic field of the field becomes stronger when the condition, this is the two core condition that is affecting the magnetic field strength. So the magnetic field becomes stronger when current through the conductor increase. So for a current, okay, there is the magnetic field lines. This is the magnetic field lines. Okay, this is I current flowing through. If we take I dash is greater than I, then the field line become closer. And for the closest line, the line closer, the field line is going to be stronger. So from here, if we take an area from here and from there, we can notice that there is the difference of the field line. The density is greater for this portion, and for I greater than I dash greater than I, the magnetic field also strong for this. And now the distance from conductor decrease. Okay, for the distance of the conductor is decreased, then the magnetic field lines become stronger. Otherwise, for the vice versa condition, the field lines must be going to be weaker. So for this, we want to know about the magnetic field lines, and now the units. We have to know about the units. If we know about some quantity, then we also have to know about the unit of the physical quantity. Okay, so before that, the important points. So this is the factor that affects the magnetic field. So near the conductor, magnetic field is strong. Far from the conductor, magnetic field is weak. That means if we take some iron, okay, piece of iron, if we take it far away from the conductor, then the attraction force must be weaker because the magnetic field is weak there. And if we take it nearer point of the conductor, then the attraction force is much stronger because magnetic field is strong there. So this principle is used in electric motors, electromagnets, generators and transformers. So that's how we can make an electromagnet. And for the electromagnet, we have to this is an electromagnet, and from when I is 0, this is going to be demagnetized. So for electromagnetism or electromagnet, there must be presence of current. Okay, so that is the electromagnets, and also the generators works in this principle. Now we have to know the units. So the SI unit of magnetic field. So the SI unit. The SI unit of magnetic field is Tesla. And in CGS, Gauss. Okay? Gauss. Relation. 1 Tesla is equal to 10 to the power 5 Gauss. So this is the relation between the Tesla, SI and CGS unit of magnetic field. So for SI unit, the magnetic field is Tesla, and for CGS unit, the magnetic field line is Gauss. So the relation is 1 Tesla is equal to 10 to the power 4 Gauss. Okay, 10 to the power 4 Gauss. Magnetic field is usually represented by B. Okay, so the field is usually represented by the B. Earth's magnetic field is about 0.5 into 10 to the power minus 4 Tesla. So we can write as 0.5 Gauss. Okay. So questions from the topic magnetic field is strongest? Far from the conductor, nearer from the conductor, at infinity, at everywhere, same. So what will be the answer? So magnetic field is strongest. This is the factor that affects the magnetic effect of the current. So what will be the answer? Can anyone give the answer? So the answer will be, we know that the magnetic field far from the conductor is weaker, near of the conductor is stronger, at infinity nearly weakest, everywhere same. This is not correct, so the answer will be near the conductor. Now the second question. If current increases, magnetic field strength, that is the magnetic field lines, decreases, remains same, increases, becomes zero. So what will be the answer? Do comment in the comment section. So what will be the answer? If current increases, so for increasing the current, the magnetic field lines are closer to each other. So that does not decreases, that does not remain the same. For the current remaining, they remain the same. Then the electric current, then the magnetic field strength must be remain the same. So this is not also applicable. So becomes zero. This is not possible because this is impossible. Why? Because of the if I is equal to 0, then only then this condition is going to be happen. So this is increase. So answer C is the correct answer. Okay? Got it? Now the next MCQs. You got it right? Direction of magnetic field depends on the temperature, direction of current, color of the wire, length of the wire. So, direction of magnetic fields depends on which factor? Anyone from the comment section? If you like the live class, do subscribe our YouTube channel Eduins CBSE. So, the options are temperature. Direction of magnetic field doesn't depend on the temperature because this is a scalar ratio itself. This is itself a scalar quantity. So, direction of current and color of the wire, this does not affect anything. Length of the wire, okay, that does connect with the resistivity but not with the direction of the magnetic field. So, this is depends on the direction of the current. So, answer B is the right answer. Now, the fourth question. Magnetic field around the straight conductor forms square pattern, circular pattern, triangular pattern, random pattern. So, what will be the answer? Anyone from the comment section? So, magnetic field around the straight conductors doesn't forms the square pattern or nor the triangle pattern and also not the random pattern. It's oriented like a circular pattern, in a circular pattern. So, option B is the correct answer here. So, that is the MCQ, that's are the MCQs for today. Okay. So, this is the topic of magnetic effect of electric current. So, today we discussed about the magnetic field and the magnetic field lines. And at the next class, we will discuss about the solenoid. Okay, so that's all for today, dear students. Hope you will understand the class. Okay, and thanks for watching. To subscribe our YouTube channel, Eduins CBSE. Thank you.